Hello everyone, my name is Nimra Bari and today I am gonna present my paper which I have submitted to CAT 2022. The title of my paper is Securing Digital Economies by Implementation of DNA Cryptography with Amino Acid and One-Time Pad. Following are the co-authors of my paper. I have done this work under the supervision of Dr. Monam Ali Shah from the Department of Computer Science of Comsets University, Islamabad. I'm gonna explain each and every section of my paper. So first of all, let's come to abstract. In recent times, security, integrity, and confidentiality is important during data transmission. So cryptography provides security using encryption and decryption. A new concept of cryptography named DNA cryptography attract the interest of mine and also the information security professionals. The main motive of this paper is to explain many aspects of DNA cryptography and implementation of a DNA cryptography using OTP for symmetric key generation, DNA cryptography to encode the data, and amino acid which DNA sequence is converted to amino acid to create confusion. So let's come to next slide, that how we can secure the digital economies. The need of strengthen and secure the digital economy is urgent. So cryptography is a method which can use to secure the data and digital transactions. So any spilled information would have been an incoherent format if the data is converted to or encrypted. So it makes useless to hackers and opposite parties. Then let's come to the introduction. In introduction, we are going to learn each and every terms which we have used in our research. First of all, what is DNA? DNA is deoxyribonucleic acid. It actually made up of nucleotide named adenine, thymine, cytosine, and guanine. The order of these nucleotides determine the DNA instruction to the body to construct the organs. And DNA is actually double helix shape consisting of two complementary strands to form the final structure. Then we have come to what is amino acid in DNA. So amino acid is an organic compounds named amino acid are combined to form protein. Amino acid play a basic role in both metabolism and building block of protein. Then we have come to amino acid DNA structure. So you can see that it's a double helix structure and have some base pairs and hydrogen bonds in it. Then comes to the one-time pad encryption. One-time pad using a key for encryption and decryption of an equal length of plain text, and the OTP key once and truly unbreakable encryption. Then comes to the what is DNA computing. So Edelman was the first scientist who used DNA method to solving the Hamilton path problem. He thinks that DNA have attractive properties like storing huge amount of data, a powerful parallel processing, and extraordinary energy efficiency. What is DNA cryptography? Due to DNA computing advantage motives to DNA cryptography idea, DNA encryption convert the plain text into ASCII code, and then convert the ASCII into the binary structure, and then convert into the DNA sequence. So in the figure we can see that how the plain text will be converted into the cipher text. Like a plain text first of all will be converted into the binary, and then the binary will be converted into a DNA format, etc. Some of the attacks done on cryptography are power analysis attack, man in the middle attack, slide channel attack, dictionary attack, statistical attack, and linear cryptographical crypto analysis attacks, etc. In literature review, we have compared the DNA cryptography technique on the basis of technique they use, encryption key they use, and the language they used. So we can see that in first row that they use DNA cryptography, RSA algorithm, and steganography. The key used are asymmetric key and RSA algorithm, and the language of implementation is Java. So further we can see that some of them used SHA-256, also AES. Some of them use bidirectional DNA encryption algorithms and OTP, etc. The key used are mostly asymmetric key, symmetric key, RSA algorithm, and some of them use Diffie-Hellman key. The languages are mostly are Java. We also use Java language, but some of them used Python, C++, and socket programming also. The proposed methodology are work in two steps: implementation of DNA cryptography with one-time pad to make the encryption and decryption secure, converting the DNA sequence to amino acid to create the confusion. So the figure below you can see that plain text well given, and then OTP will be generated, then will be converted to ASCII code, binary code, DNA format, etc. So let me explain the flow chart more deeply. So our system will be start by giving the plain text to our model. After that, the plain text will be replaced and the OTP will be generated and stored. Then the plain text will be converted to the ASCII code and then converted into the binary format. Then the OTP and the binary format will be XORed with each other. Replace the binary value by ATGC, means DNA format, DNA hybridization. After that, DNA hybridization will be converted into the amino acid value to create the confusion, and ciphertext will be generated. In decryption, the ciphertext will be given as an input. The amino acid of DNA nucleoribonucleic acid conversion, and then reverse DNA hybridization will be done and replace ATCG by corresponding binary value, and the OTP will be given by the decryption. After that, XOR of binary text and binary OTP key will be done, converting the binary value to the ASCII and then the normal plain text format. Reverse the text replacement, and after that, plain text will be generated as a decrypted form. The results are given in this slide. This is an example or a encryption we have done in our system. So in encryption process, we have given as an input plain text as an input, then the plain text will be replaced. After that, a random OTP will be generated, and the plain text will be converted into the DNA format, and in DNA format will be converted to the amino acid. The encryption final output will be in amino acid format. In decryption, the input will be both OTP and the amino acid format encrypted text. After that, these two will be used to convert the encrypted text into decrypted format, and after that replacement will be done. So the output of the decryption will be the plain text which is given to the encryption. This figure, different algorithms like AES, RSA, and DES are compared with DNA algorithm on the basis of encryption and decryption time. You can see that the encryption and decryption time of DNA cryptography is very less than the AES, RSA, and DES algorithms, etc. So in conclusion, we DNA is used as we have discussed before, and 1 gram of DNA molecules contain 1021 DNA bases, which is almost equal to 108 terabyte. So the some gram of DNA can store the data of the whole world. So due to the DNA computational advantage, DNA cryptography idea is comes, and in this paper we explained that how it work, also compare different DNA algorithm method with the proposed in previous papers, and also implement the DNA cryptography using one-time pad and amino acid sequence using Java language. The OTP is used for symmetric key generation, and DNA sequence is converted to the amino acid sequence to create confusions, etc. These are some of the references mentioned. So this is the whole. So these are some of the references we used in our research. Thank you. If any question, please feel free to ask. Thank you so much.